Hi, I'm David Manti with Industrial Equipment News, and welcome to the second episode on our series about quantum computing and the impending quantum apocalypse. With me today is Alan Grau, the VP of IoT with Sectigo. Thank you very much for joining me again today, Alan.
Thanks, David.
All right, so let's jump into it again. How does quantum computing threaten the security of specific industrial devices?
Well, really what it comes down to is, industrial devices require secure communication. And secure communication in the vast majority of use cases requires digital certificates for authentication. So as two devices start to communicate with each other, they'll exchange a digital certificate and use the encryption that's specified in that digital certificate to authenticate with each other and to establish that communication session in a secure fashion that can't be hacked. Now, what is underneath that is usually either ECC encryption or RSA encryption, and quantum computing enables breaking those algorithms very, very quickly. With today's traditional computers, breaking ECC or RSA encryption is a monumental task, and with quantum computers, that becomes something that can be done very, very quickly.
Can you tell me a little bit more about how current RSA and ECC encryption schemes are being used in, what is it, PICI?
Yeah, well, in PKI or
PKI.
Public Key Encryption.
Oh.
So, yeah, when with PKI, the way that it works, it uses public key encryption algorithms or PKI, and with that, each communication party, if you and I were communicating, if we were the two ends of the connection, each of us would have a key pair. With public key encryption, there's a private key and a public key. And the way that it works is I share my public key with you. You can use my public key to encrypt a message and send it to me. I can then decrypt it using my private key. And my private key is secret, and I never share that with anyone. And then you do the same. And so it's a very specialized encryption mechanism where, again, because I have the private key or because you have your private key, you can validate who you're communicating with, and that encryption can't be broken. No one can decrypt it without the corresponding key in that public-private key pair. So it's a very specialized type of encryption.
I apologize for that. I'd like to say it was a typo, but really it was just a testament to how far my penmanship has fallen off the cliff. That the K looked like an ISC. So, we're talking about it at a very technical level. Do you fear sometimes that it kind of goes over industrial professionals and manufacturers' heads in terms of it's too much, so they don't even understand the problem?
In some cases, that is a concern. But what we are seeing, people in the industrial space investing more heavily in security, either outsourcing to bring in the security experts or hiring security experts that understand the terminology, the technology, and how it's applied. So, industrial manufacturers are making strides in that way, in that area. And then there are a lot of third-party vendors who are providing solutions that understand the technology and that are able to help with that.
Okay. Well, so how does quantum computing then shorten the time needed to break these existing encryption schemes?
Yeah. So, well, if we look at RSA encryption, RSA encryption with a traditional computer could take, if you have a message that's encrypted using that public-private key pair, the underlying math problem that makes that really hard to break is factoring large prime numbers or factoring large numbers into its primes. And that's something that traditional computers with, say, an RSA 2048 key, a key that's of 2048 bits long, could take millions of years to factor that. Quantum computing, somewhere in the next 5 to 8 years, will be able to solve that same problem in a matter of days and even minutes, just depending on how far quantum computers advance. So, they take a problem that's astronomically hard and make it, extremely trivial to solve in terms of computing time. And quantum computers are very unique. They can solve some problems a little bit faster than traditional computers, but then other classes of problems they can solve just tremendously faster, many order of magnitudes faster. And that's true of RSA encryption and ECC encryption.
Okay. So what is AES encryption and how is that used?
Yeah, okay, so that's a great point. So when you set up a communication session, and again, this is true if two industrial devices are talking using TLS, or if you go to your online banking site, with your standard web browser, you're still using the same underlying technology. So the RSA and ECC encryption are very secure and allow the two devices to communicate securely, but it's a very computationally expensive method of doing encryption. So what we do in these systems is we use either RSA or ECC to establish the initial communication session. And once it's established, we generate and we share an AES encryption key. And AES encryption is what's called symmetric encryption, meaning that we both have the same key. So in other words, I encrypt the data on my end using AES, send it to you, you decrypt it using the same key that I use to encrypt it. So that's different than the RSA or ECC, where we each have our own half of a key. We have a public-private key pair, and we don't share the private key. But AES encryption is much faster. So you do the expensive computational encryption to start up the process, but then once it's up and going, all the rest of the data that's transferred is done using the much faster AES encryption.
Is AES immune to quantum computing?
It's not really significantly affected by quantum computing. That's one of the unique, because it uses very different mathematical processes and properties. AES encryption will break it a little bit faster, but maybe 2 times or 4 times faster based upon the research we've seen so far. So so the implication then of that is, as we move forward, we need to change the encryption in our PKI system. We need to change out and use something different than RSA or different than ECC, but we will be able to continue to use AES encryption.
Okay, so it's not an overall security PKI solution.
So the PKI security solution uses multiple different types of encryption. So the PKI part uses RSA, it uses ECC, and those have to be replaced. But when you look at the encryption used for like TLS or SSL, and what we used to call SSL, that part that uses AES doesn't have to change. So we don't have to change all of the components of the security systems and the encryption systems, but we do need to change the PKI pieces.
Okay. Well, thank you very much for joining me today, Alan. And stick around for next week. We're going to talk about why industrial OEMs need to act now. For Alan Grau, I'm David Manti, and this is the Industrial Equipment News, Quantum Computing, and Quantum Apocalypse series.